Do you know what the Cybathlon brain-computer interfaces race is? Cybathlon is a project of Swiss Federal Institute of Technology Zurich. This project challenges teams from all over the world to develop assistive technologies suitable for everyday use with and for people with disabilities. Among them, the brain-computer interfaces race is an international championship where people with severe physical disabilities compete with the aid of state-of-the-art assistive technology. Any mobile technology that measures brain activity can be used. For example, electroencephalography, magnetoencephalography, functional near-infrared spectroscopy, electrocorticography, microelectrode arrays. Electroencephalography is a technique for recording and interpreting the electrical activity of the brain. To record the electrical activity of the brain, electrodes are attached to the scalp. Each pair of electrodes transmits a signal to one of several recording channels of the electroencephalograph. This signal consists of the difference in the voltage between the pair. The rhythmic fluctuation of this potential difference is shown as peaks and troughs on a line graphed by the recording channel. Magnetoencephalography is a non-invasive medical test that uses a superconducting quantum interference device and a computer to measure neuromagnetic activity within the brain. Magnetoencephalography detects, records and analyzes the magnetic fields produced by electrical currents in the brain. The distribution of these magnetic fields is superimposed with an anatomical image of the brain to help identify the source of activity in the brain. And magnetoencephalography study is a direct measure of brain function and the most advanced method of recording and evaluating the brain while it is actively functioning. Functional near-infrared spectroscopy is a non-invasive brain imaging technique that measures blood oxygenation changes similar to functional near-infrared spectroscopy. The technique is based upon the changes in absorption of light emitted by sources onto the surface of the head and measured by detectors. Functional near-infrared spectroscopy uses fiber optics to carry the signal from a head cap worn by participants to the recording instrument. Electrocorticography is after craniotomy, and removing part of the skull of the patient. Electrodes are surgically implanted on the surface of the cortex. Electrodes may either be placed outside the dura mater or under the dura mater. The procedure also uses transparent grids that are numbered at each electrode contact. Electrocorticography signals are composed of synchronized postsynaptic potentials of pyramidal cells. Temporal resolution of electrocorticography is about 5 ms and spatial resolution is about 1 cm at the cortical surface and 0.5 to 3 mm in measuring local field potential using depth electrodes. A microelectrode array is a grid of tightly spaced microscopic electrodes embedded in the bottom of each well in a multi-well made plate. Cells, such as cardiomyocytes or neurons, which are electrically active, can be cultured over the electrodes creating a cohesive network. The functional behavior or electrical activity of this network can be recorded. Compared to electroencephalography and electrocorticography, implanted microelectrode arrays allow for higher information transfer rates, enabling more precise neural decoding and greater control of functional abilities.